All right, hello, this is Mr. Hebner, and it's pandemic 2020. That's why I'm wearing a mask. Normally I don't do that. What we got going on is how to write equations. But there's a few symbols that we need to get down first. Okay. So first thing is going to be reaction arrow. All right, yeah, this is in the packet. So a reaction arrow just separates the reactants from the product. The Mr. Hunter there.
Yeah.
Yeah, we gotta open up the purple packet. There it is.
Is that on the video?
All right.
Wait, what is the first one say?
First one, reaction arrow. It separates the reactants from the products. So reactants are what you start with, products are what you end with. And it also means yield, to produce. So, what happens if you have a double arrow? That means reaction. So reaction inverse means it can go both ways. The reactants can form the products, and the products can turn back into the reactants. So we're not really going to be seeing this reverse equilibrium symbol. You got to wait till AP or AB Chem before we do that. All right, S means solid. This is the solid state of matter. An example would be H2O S, meaning that's ice, solid. And then that's an L, that's cursive. And we got liquid. Example would be H2O, liquid. What do you think G stands for? Gas, you got it.
What is the one above that?
What's that?
What is the one above?
Liquid.
That's an L.
That's an L, yeah, cursive L.
Do we have to do it in cursive?
You can have it in regular L, yeah. Alright, and then we got AQ is aqueous, meaning it's dissolved in water. Example would be silver nitrate.
Is that AG?
AQ, it's a cursive Q.
Does it have to be cursive?
No, it doesn't have to be cursive. They don't teach cursive in fourth grade anymore.
They do, but only so you can learn your signature, then you forget it.
What does that even say?
Aqueous. Aqueous.
Aqueous?
Yep, dissolved in water. Alright, if you have a reaction arrow with a triangle above it, it means heat is required for the reaction to occur. None of this factors into balancing. And then if you have a chemical formula, an example would be MnO4 on top. That means it is a catalyst that speeds up the reaction. Or in some cases allows the reaction to even occur. So does MnO4 factor, does it turn into a product, react with the reactants? No. It's a cheerleader. It allows the reaction to happen faster. So, kind of like our cheerleading team allows our football team to do better. Although they're all quarantined, so that might not happen.
What is it? The one say?
Chemical formula, MnO4.
What is
Yep. All right, we can leave this last one blank.
We ended the video.
Almost. So we got diatomic elements. So I try to stay away from memorization, but one thing that you will have to memorize is the diatomic elements, and there's 7 of them. And I did have a little periodic table here. Oh, where did it go? Let me get the periodic table. All right. So there are 7 diatomic elements, and they make a 7 on the periodic table. One of them is hydrogen. The other is nitrogen, oxygen, fluorine, chlorine, bromine, iodine. And you can see they make a 7 on the periodic table because there's 7 of them. All right. So we write that down. There's H2, N2, O2, F2, Cl2, Br2, and I2. Those are the 7 diatomic elements. So, if you see them, something written as like hydrogen gas, it's got to be written as H2. But if you see something as, I don't know, hydrogen bromide, it's not necessarily going to be H2. So, example would be,
H2O.
yeah, well, H2O, that's a coincidence. But, so if you see hydrogen gas, you're going to write, oh, that's H2, not H. Because hydrogen gas by itself in nature is always H2. Yeah. All right, but hydrogen bromide, it's not going to be, oh, H2Br. I got to go back to my naming. I got hydrogen. I got Br. Hydrogen's +1. Bromine's -1. And it's balanced. 1H, 1Br, HBr. So the only time it's going to be H2 is if it's by itself, hydrogen gas. With that being said, we're going to do one example, and this also pertains to what's on next week's test on Friday, is putting it all together. It's putting the naming, formula writing, balancing into one thing. Here's an equation. Hydrogen gas reacts with oxygen gas to form liquid water. So how am I going to write hydrogen gas? Just like H, right? No, it says hydrogen gas, so I got to write H2. And I got to show the state of matter. If they tell me the state of matter, like gas, I got to write the little g. If they don't tell me, then I don't write anything. Okay.
If you ever get hydrogen as a solid,
You could, yeah, if you get it cold enough. I know you got Neptune, they've got, and Pluto, they got nitrogen glaciers. So not quite hydrogen, but nitrogen. So they would have to be really cold because a lot of the, like Jupiter has a lot of hydrogen in it, but it's not solid.
C.
So you'd have to be really, really cold.
Okay.
Oxygen gas, how do I write oxygen gas? O or O2? O2, because it's a diatomic element. Hey, what's the state of matter? Gas. Alright. And it forms liquid water. Hopefully you end this class knowing at least the formula for water being H2O. Hey, it's liquid. What's the state of matter?
L.
L. Alright. I'll go with manuscript L. There we go. So what do you always have to do to equations? Balance them. You got to balance it. So we wrote all the formulas. Now we got to balance it. We got 2 H's, 2 H's, 2 O's, 1 O. How do we get 2 O's here? We can't put a 2 there, but we can put a 2 coefficient. There you go.
And then you got to double the H.
There you go. 2 times 2 is 4. 2 times 2 is 4. And it is balanced. Then we're also going to be able to state what type of reaction it is. It's a synthesis / combustion. We'll talk about that on Friday. Types of reactions. All right. So that's a sneak peek at writing word equations.